Okay, welcome to today's lecture. I managed to get to Växjö today as well. However, next week I will probably not, because we have oral hearing week in Kalmar. So I will probably pre-record one of the lectures next week and have one recording since last year, because that is accurate still. So let's go over just a few things. I will not get into details. Probably all of you, or more or less, did the hand-in of the examination assignment this Friday, last Friday. I would like to stress that please read the instructions, because it says really clear what to do, how to hand in the examination assignment. That is the same for all assignments in the course. So if you did it on this one, you will be sure to have done it, or you will do it the right way on the other ones as well. You are supposed to hand in the code on the repositories given to you on the organization 1DV525 on GitHub, not your own repositories, because then we have no follow-up at all. So we really need you to use the repos that we have generated for you. Last week we also had this 3-week rule thing. So I think Mats is removing inactive students from the course right now. That is students that have not made a commit yet. So if you've made a commit, you're safe. But if you haven't, then you will probably be unregistered today. If you are and you want to complete the course, please contact us. But if you haven't done a commit yet, 4 weeks into the course, with 5 weeks to go, you are probably behind quite a bit. Today we will transition to part 2 in the course, the client-side JavaScript. This is when it's getting exciting. Everything leading up to now has just been like preparing for this part. So the fun starts now, and today I will have the lecture 5 and 6. The reason those are grayed out is that there are some references that I will update. And I've just updated the lecture, the presentation for the 5th lecture. So if you're following along, you can bring up the presentation. It's accurate, I think. So probably lecture 7 and 8 will be pre-recorded, so that you know. That means that if you want to be ahead, don't wait with lecture 7 and 8 until next week. You could probably squeeze them in this week if you like, and start working on the exercises and start working on the assignment. So first of all, I recommend you all to do the exercises in the course. So the exercises are kind of designed so that if you do the exercises, you get all the tools for creating the assignment, or creating the application in the assignment. If you feel stressed and out of time and just skip all the exercises, well, you're allowed to. We will not have anything to say about that, but the examination will be quite hard then, I think. So please do the exercises. And the exercises, that is nothing you need to hand in or show us or anything like that. It's for your own eyes only. There are like 6 or 7 exercises. They are graded with a level, and A level is like the bare minimum and the basics. So please do all the A level exercises. Even I would say the B level exercises are quite important to finish the examination exercise. And we don't have any C level yet, but there might be, and that is kind of extra. If one C level will show up, it's more or less extra in that case. For all the, not all, but for many of the exercises, you will get an extended recording, a demo, where I solve that exercise from the start to the end. so you can follow along. So I will not code so much on the lectures to come. Instead, I will please recommend you to watch the recordings, because then you get my view on how to write the code. Of course, you can have a different view, and you're free to do so. But if you want one way ahead, then you could watch the recordings. And I kind of show the development tools and stuff like that in those recordings. There are some, I mean, some are a couple of years old. Most of them I recorded last year. I will record some new this year as well. There are no big differences, but there are some differences that comes down to how the development environment is set up. We are using Webpack in this course. I will introduce something called ECMAScript modules today that kind of eliminates the need for Webpack. However, we are using Webpack still, and I will talk to you about that later on. So just beware when you watch the demos that what I say on this lecture is more how you're supposed to do it. All the exercises are updated with the latest code, so please just go ahead and start doing them. You get the instructions for each and every exercise in its repository. So it has a README, and the README will kind of say what to do. Okay. And the deadline for the examination. This one is grayed out as well. I have some minor bug fixes to do in this one, coming down to the requirements, because the requirements have some leaks in them. So if you want the minimal path, there are some ways of getting past some of the requirements, and I will kind of fix those. But otherwise, it's the same assignment, and it should be up and running, so you are able to start on this one now if you like. Deadline 10th of October. And that is actually the same day as we have the oral hearings. So you need to have submitted your code at latest 7:30. The same day as the oral hearings. And I will get back to you on how to book oral hearings as well. Questions regarding the course in general? Okay. Then we will dive into today's topic, and today's topic is the browser and JavaScript. So last week we talked about JavaScript, but more like the language JavaScript, and getting you up to speed with constructions in the language, syntax, and how to write JavaScript in general. Today we will transition to the browser and talk about how to implement JavaScript in the browser. And the browser is probably the most common environment for JavaScripts to be executed, even though the server environment with Node is quite popular as well. And it was in the browser that it all started. So today we will have a look at the browser, and we will have a look at components inside of the browser to be able to understand how JavaScript is working together with HTML and CSS. We will have some look at the development tools as well. Just a quick look. I think I have some references that you can check out if you would want a deeper look into development tools in the browser. And then we will transition and start working with JavaScript in the browser, and just getting started with it, and where to write our scripts, and what differs JavaScript in the browser from other environments. I might have said this before. Oh, sorry, I will change the view to that one, maybe. Yay. Douglas Crockford, I talked about him last week. He's been kind of an evangelist for JavaScript, or has been at least. He is now working at PayPal, I think, and the reason he chose PayPal was that they said he could do whatever he liked there. So he kind of is employed at PayPal, but he's doing whatever he likes. He said this: the browser is a really hostile programming environment, and you will find out that if you're used to Java, C# or whatever other environment, you are kind of in control as a developer. You know what version of Java is running, and you can compile your code to run in that version, and everything is fine, and you will know that, okay, as long as this version of Java is present, everything will work out fine. However, in the browser, we have this kind of openness, so everything is open standard, meaning that we have a lot of different browser manufacturers. With all of those browser manufacturers comes different bugs, different implementations, especially if you go back a few years in time, where kind of Internet Explorer and Microsoft did it their way and other browsers another way. Today, all browsers are kind of equal in when they support something, they often support it in the same way because the standards are much better written today, and error handling and stuff are all more controlled. However, there are still problems with compatibility, that some browsers are not supporting all the new features in the language. And I'll have more discussion about this later on, but just bear in mind that when you are developing for a browser, if it works for you, it might not be the same if you're in a phone or if you're in another desktop computer or wherever this code is being executed. And one thing with the web as well is that a lot of sites are built upon the notion of including frameworks and libraries from many different vendors. And to get those working together without bugs has also been quite a problem, at least before. Now we have better package handling and better modules in the browser, but that was also a big problem, especially a couple of years ago. But we will try to get through that in this course, or at least have a look at it. So, I showed this picture before. This is, I actually talked to a developer at Meridium, that is a company in Kalmar, quite the big company, and he had, the guy I talked to, he's working with web, because everybody's working with web in some way, and he had been hiring Java developers with no prior experience to the web. And what he said was that the most difficult problem to overcome is the notion of the server and the client model. That you're so used to think in like one monolith application that it's hard to imagine code running on the server and the client, and how these interact and how you can have latency between calls and stuff like that. So it's really, really important that we think about where the code is executed. So from now on, all code we write will execute in the browser on the client. The code I wrote last week was actually executed on the server or in the Node.js environment. However, from this day on, everything we do is in the browser. Of course, you will kind of fetch things from the server. In some cases, I've written servers that you will communicate through for making chats. And the second assignment, for instance, where the second assignment is a simple question, what's it called? Poll? No, quiz. A quiz application. So you get a question, and the user should answer that question. You have a timer, and then you click next, and you get a new question. The user answers that question, and all of those questions are served from the server to your application in the client. So there is no way of like looking in the code on the client and finding all the answers, because the answers and the questions are not present in the browser. They are being served from the server. Of course, you will not write the code on the server. You will focus on the client. But in the other course, the next one, 1DV523, we focus on the server instead and writing server applications, for those of you taking that course. Okay. Now we're in the browser. Yeah. Which browsers do you use? So just a simple hands up for Firefox. Okay. Chrome? Yeah. Safari? No. Internet Explorer? Ah, well, come on. Edge. Yeah. Opera. Yeah. Tor browser or some kind of, no? Anonymous. Brave? Yeah, Brave, the Lion thing with, yeah, I've been testing it out. I think it's a Firefox fork. Yeah. Any other browser I missed? Anyone using the Samsung browser in the phone? Having like a Galaxy 8 or something like that? Yeah. Is it different browsers in phone versus desktop, or are you using the same browser in both? Those of you who are using the same browser, desktop and mobile, hands up. Okay. Those of you, yeah, and the rest of you are switching. Yeah. Okay, so let's just have a look at some numbers, because it could be quite interesting. Oh my God, it didn't fit. Okay. Yeah, most of you put your hand up with Chrome, and it's being the most popular browser by far, almost 70% worldwide usage. This statistics is, and that is gone as well below the horizon, but it's the global stats, global stat counter or something like that it's called. So always beware when it comes to statistics. Of course, this, I think they measure on quite a lot of sites, and I've found this quite accurate over the years. But of course, if you were to look at browser support on a developer site, for instance GitHub, this will change dramatically because developers go to GitHub. But I think this is quite a fair representation of the percentages. So it's also interesting to see Sweden, because that is the context many of us are developing in. Chrome being not that popular in Sweden, however, Internet Explorer is being a little bit more popular. And I guess this is due to many IT companies in Sweden being, or companies in Sweden adopting web technologies quite early on, and they are now sitting in a lot of old systems that only run in Internet Explorer, so they are kind of forced to still use Internet Explorer. That will probably change. Those numbers are dropping each year. It was 14% last year, so give it a couple of years and I think Internet Explorer will be gone totally. But it's still there, 10% in Sweden. That is actually quite a lot. Anyone know that one? No, but it's Alibaba, the big Asian company. It has its own browser. And, oh, I didn't say, but inside of the parentheses is the mobile numbers. Once again. Okay, so it's good for browsers without JavaScript support, yeah. Or phones without that don't need JavaScript. We will not look especially on that one. UC browser, I think it's called, actually. UC. Firefox being 11%. Yeah, you can see the numbers for yourself. Opera getting lower and lower for each year. At Edge, the new Microsoft browser, is gaining ground slowly. I guess some are transitioning from Internet Explorer to Edge. Down below is Samsung, not being showed. Of course, it has nothing on desktop, but on mobile, I think it's like 3 or 4%, something like that, in that area. Noticeable is that there are some things differing Sweden from worldwide, and it comes to mobile browsers especially. And it's regarding Safari. So iPhones has always been quite popular in Sweden, and this is shown in those numbers. So Safari having, or iPhones, or Apple having like 20% of the global mobile market, but in Sweden it's closer to 50. So it's quite a difference there. What would I recommend? I wouldn't recommend anything. I would actually recommend trying out different browsers and switch. Just to get a feeling for different browsers. We will look at this is kind of only branding, so it's more interesting to look under the hood and see what kind of engines are those browsers running, and some are sharing engines. So I would say developers tend to have used Firefox a lot, and many have switched to Chrome. Yeah. Okay, so the UC has some kind of support for playing games on desktop, or?
Yeah, this you can play, for example, games you can play on Facebook.
Yeah.
But you can't play in the others.
Ah, okay. Yeah, so that is more or less a small operating system in a way that you could have like application specific for that one. Yeah, that has proven quite a bad idea through the years. I mean, Internet Explorer tried it with its like COM components and stuff, and it kind of didn't work out. So probably most of those big browsers are quite into following standards and not doing things on their own from now on without changing the standard before. They might try things out, but they are often trying to get that into the standard. Opera being one of those that kind of drives some areas and experiments a lot. The reason Firefox was really popular back in the days, if we go back 10 years, it was that it was the first browser that supported or had plugins that supported debugging in the browser in a good and structured way, using a plugin called Firebird. Firebird, I think. Firebug.
Maybe sometimes the Firefox is faster than Chrome.
Yeah.
Open the computer, Firefox open.
Yeah, and I repeat for the mic. So the company says sometimes Firefox is faster, boot up times when you start a computer, and memory handling might be better in Firefox sometimes, but then Chrome might be better in some way. I mean, it's a constant race, and especially the race is on when it comes to executing JavaScript in an efficient way. So the amount of money and effort being used to optimize the JavaScript engines are really, really big. I mean, they are doing a lot of things. I will get into this, but I have a reference to a talk on Nordic.js, I think it was last year, where they compared C++ to JavaScript in the browser. And in certain applications, JavaScript was actually faster, which is quite nice, since JavaScript often is, I mean, it's C++ in the background anyways, but for certain operations, JavaScript is really fast today. It wasn't 15 years ago, but today, doing calculations and stuff, JavaScript could be really fast. And that comes down to optimizations in the browser's JavaScript engines being the driver for this. But we will have a look at that soon. Just some words about compatibility. I will not, like on every API call, I will not stand here and teach you which browser support what, because it's changing all the time. There are actually techniques that I couldn't teach last year that are supported mainly in all browsers today, just a year later. So that kind of knowledge is kind of something you need to update yourself with every day when working on the web. However, I will recommend caniuse.com. We have had a look at that before, so please use it. If you're uncertain for a specific API call, for instance, you can use caniuse and you can see which browsers support that API call. Also, make sure you use developermozilla.org. I've recommended it a lot. You will see a compatibility chart on all methods and classes and types there as well. And there are probably better sources out there. Okay. Let's head into the browser then and look at the, I mean, as I said, Chrome and Internet Explorer, that's only branding, more or less. The more interesting parts is what is beneath the surface and what is building the browser. And I've made this distinction of components in the browser. This is from a conference paper. It's the best one I've found, just concerning the different parts of the browser. And this is good enough, I think. So we have some kind of user interface, of course. I mean, address bars and buttons and all the things that you see, scroll bars and things like that. That is often one of the things that are quite commonly changed with branding. That I think Chrome on Mac at least did an update last couple of days ago and changed the UI completely. We have something called browser and rendering engines. And browser and rendering engines is the one that is responsible for parsing, retrieving and parsing the HTML and CSS. And also calling the JavaScript engine when needed. The JavaScript engine being the just-in-time compiler, interpreter for JavaScript. A couple of years ago, or 5 and 10 years ago, we could say that JavaScript was an interpreted language, that it was like just interpreted in real time as it was executed, from code to the running or the execution. However, in the later years, this has changed. So you cannot say that JavaScript is barely an interpreted language. It's also a compiled language. Many parts of your code will be compiled in the background without you knowing it, just for optimization. Could be quite good to know. Nothing that you should really need to worry about when you are developing, but it could be good to know. We have a network layer. This one is responsible for all network traffic and fetching things from the server, opening socket connections and things like that. And we have data persistence layer as well, you being able to store things in the browser. This typically being cookies. Today we have much better ways of storing things in the browser, like web storage and even a cache, to be able to control what is cached in the browser and what is not. Maybe you want to cache some images so you don't need to load them over and over again. You can control that in a really, really good manner today. Okay, this is a graphical illustration of those components. Not much to say about this, more than those two, the browser engine and the rendering engine, depending on where you read, those will sometimes together be called the browser engine, and sometimes they are divided into the browser engine and the rendering engine. And the distinction being browser engine being the composer that like looks, oh, we have a JavaScript and then we have a CSS file. Oh, I should fetch the image, and just doing that work. And the rendering engine looking at the specific code, fixing your errors if you have made errors in the HTML. Remember, if you write full HTML, the browser will fix it for you. That being one of the jobs for the rendering engine. And just preparing everything for the UI backend to plot it on the screen with dots, more or less. So this is pretty much where a lot of HTML and CSS magic is happening. And in the JavaScript engine, of course, all the JavaScript is executed. And we will, in this course, mainly focus on the yellow one, the JavaScript engine, because, well, that's where our code will be executed. I'll skip that one. So, looking at the browsers once again, those are the components names, many of them open sourced. So, if we look at, for instance, Chrome, we can see that both Chrome and Opera are using the browser rendering engine called Blink. Google used to use WebKit if we go back, I think like 4 or 5 years ago, Safari and Chrome both used WebKit. However, Apple and Google couldn't get along. So Safari wanted to have WebKit like really stable and backwards compatible with old legacy code. However, the Google development team wanted a more progressive approach, so they split that project. WebKit is an open source project, so anyone can, and Blink as well, so anyone could participate, of course, and everyone can fork, and they did a fork. And I think when doing that fork, they removed a lot of code from WebKit. So I think Blink, at least then, was quite a bit smaller in the number of rows of code, at least. When that happened, Opera abandoned their own rendering and JavaScript engine and jumped on to the same engine as Chrome, that being Blink for the rendering engine and the V8 JavaScript engine. And V8 is probably the most known JavaScript engine. It's open source, and it's the one that Brian Dahl used when he created Node, the server version of running JavaScript on the server, basically. So it's V8 being the JavaScript engine in both cases. However, it's different. It's not exactly the same engine. I mean, there are forks of this, of course, but more or less, it's more or less the same, at least. You see the names, something else to say, well, if you were to, for instance, so the rendering engine for Firefox is Gecko. And if you were to if you had a web server and you got a call from a Internet Explorer browser, and you could always get information about the browser because the browser sends information amongst other things which browser rendering engine is being used. So when Internet Explorer is calling a server, it should say Trident because that is the rendering engine. However, it doesn't. It says Gecko. And that is quite strange because Internet Explorer has never had Gecko implemented as a rendering engine. Still, it identifies itself as a Gecko browser. And this is, first of all, one reason why it's really hard to trust the browsers when it comes to the server and knowing what browser it actually is. But this is due to the old browser wars. When Firefox, or in that case Netscape and Internet Explorer and Microsoft fighted for getting the control over the web. What happened was, I think I've mentioned this before, but what happened was that, they tried to implement a lot of cool stuff into the browser so that the developers would shift and use their browser instead. So, now Microsoft has implemented Blink. Yay! All the developers wanted to use blinking text, so they switched to Internet Explorer. However, many developers developed sites that would only work in Netscape that used Gecko. What the developers did then was to be sure that it wasn't an Internet Explorer that tried to run this code and that would break because Internet Explorer didn't support some of those things that the developers did. They had a simple if statement. So if this browser rendering engine contains Gecko, okay, fine, let it through. If it's not, just show a please switch to Netscape sign instead. But when Internet Explorer matured and started to support the same features as Gecko, they were not let in on those sites because they were not a Gecko browser. So they did the obvious thing and they added Gecko to their rendering engine signature. So they were let in on those sites. And that's why still later versions of Internet Explorer has this Gecko thing to not break old websites that still rely on that old code. Of course, this is a terrible way of doing what is called like browser detection. So you detect what browser it is, and you make choice depending on browser vendor. That is a terrible way of handling compatibility. What you're supposed to do is to check for feature detection. So if a browser supports a certain feature, then you can serve that content. Otherwise, you have a backup. So that is kind of browser detection versus feature detection. Okay. What you would need to know is that V8 is a JavaScript engine, because that is like the JavaScript engine. But remember, there are others. You don't need to memorize those. It's also good to know that Opera and Chrome is using the same rendering engine. Hence, you shouldn't need to test your HTML and CSS in both browsers. Should always look the same. But the UI being different could be good to test anyways if you're developing a big site. Okay, questions? Or we will move on to why we have JavaScript in the browser. Why is JavaScript in the browser? Because of reason. We need to still go back to 1995 and oh, I haven't told this story in a couple of years, so I hope I'm not saying this wrong. It could be. I'm pretty sure that we are in Netscape territory. So Netscape wanted an advantage over Internet Explorer, and they wanted to be able to run code in the browser. Instead of just showing information that was common back in 1995, they wanted an overhand in being able to execute code in the browser. Another initiative called Java Applets was being introduced. Java Applets being Java code being run in the browser in a separate sandbox. However, it was quite cumbersome to work with. It was really not, it was more or less a plugin with like a box where you could run code, instead of integrating the code into the page itself. So Brendan Eich, being I think a developer at Xerox back in the days, he got the question to if he could implement the language into the browser, in the Netscape browser. And he was actually constructing languages, so he thought it was quite a neat challenge. So he started working with a new language that he called LiveScript, and that actually had its roots in Scheme or Lisp, I don't really remember, or both, but in a totally different stem than Java and C# and those languages. So Scheme is quite different. It's a functional language. So he started to developing that language, and he showed it for the executives or whoever made the decisions, and they said kind of, but this doesn't look like Java, because Java was really the thing back in the 90s. And he said, no, it's a totally different language. No, but we need to have it to look like Java, because otherwise the developers will be frightened. They will not know how to develop in this language you constructed. It must look like Java. Okay, so back to the drawing board, and he redesigned the language so that it's actually a functional language in the if you look beyond the syntax. However, the syntax is kind of like Java, and you know that now because you have programmed or looked some at JavaScript, and I know you know an if statement is an if statement, a for loop is a for loop. It's kind of the same, and that's why. And they even named it JavaScript, just to get a little bit on the brighter side, because everybody liked Java. And that was fine, because when Sun had the, I think it was Sun back in the 90s that owned Java, and they gave their blessing to calling it a Java script. That was fine with Sun. But that was in Netscape. And Sun and Netscape, they had some kind of relationship, I don't remember. However, when Microsoft saw this initiative, they thought, oh, we also would like to implement JavaScript in Internet Explorer. So what they did was reverse engineered JavaScript from Netscape. And they did a pretty good job, because they reversed engineered everything. Every error, every fault thing in the language, they reversed engineered. But they couldn't call it JavaScript, because Sun owned the brand Java. So they had to call it JScript. So in the 90s we had JavaScript, that we had the name Livescript floating around because that was the initial name, and then we had JScript, that was Microsoft's version, that was totally the same thing. But then they started to divide, Microsoft having quite a pragmatic view on how to program on the web. They in many cases did their own thing, whilst Netscape more worked with a standard committee and tried to do it that way. So 15 or 20 years ago, the community was really divided. It was really hard to program for the web, because we had JScript, we had JavaScript. JScript had some implementations that wasn't supported in JavaScript, and back and forth. However, that is long gone, and today JavaScript, or ECMAScript, that is the standard name, is being implemented with new features coming and being released each and every year. So this year it's ECMAScript 2018. No big news in that one, but some releases are bigger than others. ECMAScript 2015 being the big release, where many things changed. But what do we need JavaScript for in the browser? Well, if we have no JavaScript in the browser, a web page is more or less only an information servant, serving documents, linking to other documents, maybe showing images. But that is pretty much what the web would look like. However, you know that the web is so much more today. I mean, look at Netflix, Facebook, Google. I mean, each and every of those application platforms are quite neat today. I mean, there is, in many cases, they are web only even. So looking at Slack, for instance, that is a web only application. Well, it's implemented in the phones and in the browser, but that is just using the web application in the background and just presenting it as a browser app, or as a phone app, or as a Electron app on the PC. So today you can do more or less anything in JavaScript in the browser. You can run application and games. We have APIs for accessing graphic cards, so you can do quite a lot with those APIs. It's not a replacement for C++ yet. However, there is an initiative called WebAssembly that that you could actually write your games in C++ and convert them to WebAssembly, and you could run them pretty natively in the browser as well. We could do things like live updates from the server. We can work with VR and AR in the browser. We can do most things that you need. And I mean, Chromebook is probably and that is Google's initiative to show that the web is actually a platform. It's not just a browser anymore. It's a platform. So the Chromebook, you probably know it, but the Chromebook is more or less only a browser, just running web applications. Well, it supports Java or Android applications now as well, but it's still an initiative to show the power of the web. When we start writing JavaScript, I will try to enforce this structure, that we separate the structure, that being HTML, from the presentation, that being from the behavior, that being JavaScript. So we're adding this last one. We're adding behavior to the structure and presentation. So the first assignment was using HTML and CSS and just creating a simple presentation page. And now we're adding JavaScript to this to make things happen. And you can make whatever you can come up with happen using JavaScript. You can move things around, you can change colors, you can make new text appear, remove text that is no longer used. You can change each and every style attribute. So anything you can do with CSS, you can use dynamically with JavaScript as well, telling the CSS to update itself. And on top of that, we have a lot of APIs that we could use as well. I will have a separate lecture on that in the end of the course, but we have APIs, for instance, in the phone you have APIs to find out the percentage of the battery. You have an API to find all or get all context in the contact books. You have an API to start the camera, to start the microphone. You have APIs for more or less everything. For the gyroscope, for instance, if you want to make a game using the gyroscope. Yeah, so that is pretty much it. This last thing before the break, what is important to know, and a big distinction between running JavaScript in a browser compared to running a Java application in Windows, for instance, is that JavaScript is heavily sandboxed. And with that I mean, if you were to just visit a page, that page can start running an application in your computer, because that is JavaScript basically. So think that, so if you're just randomly surfing the web, you're coming to a web page that starts an application. If that application had unlimited rights on your computer, it would be really dangerous, because it will be able to start the camera, listen on the microphone, start changing files on your file system. It could do whatever it liked. In the browser, it's not like that. We need restrictions, because otherwise, whoa, it wouldn't be good. So for instance, JavaScript cannot read from the local file system. Well, there is an API for that soon as well, but you cannot like just start a file reader and read a file like you can in Java. You cannot do that in JavaScript. It's not allowed. There are certain APIs that you can access, but you can't access them without the user permission. And you probably know this, especially if you have a phone, because the phones are kind of designed the same way. So if you try to use the webcam, the user will get a question, is it okay to start the cam? And the user clicks okay or deny. You need to know that, because if the user denies, you need to have a backup plan. Okay, so the user should take a profile picture of itself. Okay, it didn't want to share its camera. Well, make the user upload an image then instead, or something like that. So you always need fallbacks for using certain APIs, and location is one of those examples. The browser JavaScript can access the user location, the GPS positioning. However, the user must click OK for JavaScript to be able to do that. Communication with third-party servers is kind of restricted. However, there are something called CORS, cross-origin resource sharing, that allows you to communicate with other servers. And we will look into this when we start working with asynchronous communications. Is it possible to bypass those permissions? No. Then it's a bug in the browser. So you always need to ask the user for permission. However, the user can, like for location, for instance, the user can say always provide location for this site.
Yeah, but what I'm saying is, like, you have programs like, I don't know, XQ score or stuff like that from the NSA and stuff. They always don't use permissions. They just check live cameras.
Yeah, so some kind of conspiracy theory going on. And yeah, but remember, are those web applications you're talking about? Or is it, I mean, if you have installed, if an application can be installed on your computer as a regular application, then it's more dangerous. However, as long as it is run in the web browser, it's sandboxed. However, the last Mac OS, Mojave, I think it's starting to utilize this permission control for installed applications as well. For instance, if in Mojave, if an application needs the camera, the application needs to ask the user for permission. So that is becoming a thing on desktop computers as well. But if you're able to bypass some of those APIs permission handling, then there is a serious bug in that browser. And yeah. Yeah, just an example before the break. You probably can't see, but that is a link, a blue link, that indicating that this is a clickable link. If you, I mean, I said you can do whatever you like with JavaScript. You can change colors, you can find out colors of stuff, but there is an exception. You cannot find the color of a link with JavaScript. You cannot read. It's a write only. You can never read the color of a link. You know why? And that could be quite strange as a developer. You're like, why can't I get the color? It's the most obvious thing. You try with a P element, works. You try with an A element, doesn't work. Because the color of the link indicates if you have visited the site or not. So you could, there were actually websites that just listed a lot of other sites, and then it looped all those links and checked for purple colors on the links. And if the color was purple, then the user has visited that page. And you could more or less find out which pages the user had visited and not on the web. Okay, you need to pinpoint each and every one of those pages, but it is still an integrity problem. And you can find things like this throughout JavaScript. So remember, if you're trying to do something sneaky, and that is not possible, but it kind of should be, it's probably due to some kind of restriction in the browser. So just have that in mind when you're programming for the web. Okay, we will take a short break, 10 minutes. After that break, we will start writing JavaScript in the browser and more see how and where to write the JavaScript. So 10 minutes break. Okay, welcome back. I got a question in the break regarding the schedule and the schedule for the rest of the course, I guess. No, screen. Why is that lagging? Come on. This happened last time as well. Okay. Well, now it works perfectly. I think. Almost. There's a strange delay on my screen sharing to the stream. It's really strange. But you can see the schedule anyways. Okay, I'll wait for those. Oh, well, it's like a minute. I really need to do a restart of the stream, so just hold on. Okay, we're back. Oh, well, now the screen is following along. Okay, so I got a question in the break, and the question regarded the examinations, the third assignment, because we have 3 assignments. The second assignment having a deadline the 10th of October, and then we have examinations booked for that day. However, on the last week, we have 2 examinations booked. And that is because we are a lot of teachers involved, and all of those teachers have other courses, and all courses have examinations this week. So we will not be able to accommodate all students this Wednesday. And since this course is designed for 10 weeks, we kind of cheated and added 1 examination hearing the week after. So if you will not be able to meet the deadline of the 31st, we will probably open up another one at the 7th of November. However, that is the next period has started. So if you're into courses that week, you will maybe have to skip a lecture or something to be able to attend that examination. So, but set a goal to be able to finish to the 31st. But we will have re-exams, and we will have re-exams on the re-exams. And there will be like re-exams all the way during the winter as well. But the more that finish in time, the better, of course. Okay, but it's all on the course page. Yeah, I got a question, but I cannot answer that right now. I need to look into that. Okay. Starting to write JavaScript in the browser. And this is, this is one of the things I changed late last night. So this is kind of up to date. And this is due to the fact that ECMAScript modules wasn't supported in a good way in browsers last year, but they are this year. So I will kind of show you how JavaScript was implemented in the browser before ECMAScript modules or ESM modules or ESM, and after ESM. And in the course we will use ECMAScript modules. It will make life easier for you. And as long as you're coding in a fairly modern browser, that will pose no problems. Okay, so but we start off with the old recommendation. I think this is how they do it in the book as well, even though they mention that you could do it with ESM. You recognize this. This is a simple HTML page. Nothing strange here. If you like, you have linked some style sheets, for instance, in the head. You have a section with content. And then we would like to add JavaScript to this mix. You can add JavaScript in many different ways. You can more or less exactly the same ways that you can do with the styles. So with styles, you can add a style on a tag, just saying the p tag has the style attribute red. We went over this and said that is not a good idea because it will be really hard to maintain that code. You will duplicate code a lot. It's the same thing with JavaScript. You can add JavaScript on HTML elements, but you really should not. So I will not even show how to do that. You can also add JavaScript using the script element. And the script element being a script start tag and an end tag. And then you just, I think I could actually write in this one. Yeah. So I could do something like, I did that last year as well. So when I press tab, everything just disappears. Okay. I will not indent using tab, but that is really hard to remember. So we could do it like this. The indentation will be hard. Console.log. Hey son. This is totally valid. We've added a script element. We have written JavaScript between the bracket inside of the element, and this will log hey son to the console. You probably recognize the console log command because that is a command that is, or an API, the console API is shared between Node and the browser. And that is because when they designed Node, they looked at the browser and did it kind of the same way. So many of the API calls in Node are mimicking how to do it in the browser. What will happen in this case is the browser will start parsing the page. It will come to the script element, and then it will stop the HTML rendering and it will execute the JavaScript. When it's executed, it will start rendering HTML once again. Once again? Yeah. So where will this show up? Well, it will show up in the console. So if you are, I've got a Swedish operating system, so it says inspectera, it says inspecting English. If you just right click and choose inspect, you will go into the development tools in the browser and you will find a console there. In this case, this is not being executed because it's only presentation. However, you can also write code in this console. So I can do a console.log hey son, and it will execute the code. And you could do like let I equals 10 console log, or we could just do, I think, I plus 5, and that is 15. So you can like write code in the console. The code is being run in the context of this page. So it's executed with this on this page. So we could manipulate things on this page using JavaScript code in the console. And if we do this, oh well, it will write in this console. And that is, of course, only for developers. So this is not a user-friendly way of greeting a user to your page, because the user needs to go into the console to be able to see that. That is one way of doing it. I might get back to that. It has the same drawbacks as when you place styles like that. If you have multiple pages, you need to duplicate the code on all pages. So you will probably not do that too much, but I have a notion that we might, in a certain case, will see the script tag once again implemented in that way. However, what we can do, just like with style sheet, you can use the script tag, you can specify source, and you can point to a JavaScript file, and that file will be executed. In this case, it will be executed when this script, when the rendering engine comes to this line, it will say, oh, here's a script, and it will pause. It will fetch the script synchronously from the server. So it will ask the server to send the script, it will receive the script, and then it will execute the script, and when it's done, it will continue to render the page. So there is a reason why the script is located at the bottom of the page, and that is because then we don't interrupt the page load. So in this case, when the user enters the page, it will show the HTML, it will show the CSS, and then it will load the script in the background and add the script to the page. If we were to add the script in the top of the page instead, we might get a delay. So the user will see a white page waiting for the script to load, and then it will start rendering the page. So you will actually get a snappier page load placing the script at the bottom. This works in browsers way back. You can do this in Internet Explorer and whatever, and it will still work the same way. I will show another way of doing this. Yeah, this is the kind of the file structure that I have. So we have a source folder for all the source code. In that folder I have the index.html, and I have a source folder called JS, and in that JS folder I place all my scripts. You can kind of do it like however you like, but this is the way that the exercises are structured. But of course you're free to change it. Okay, another way of doing this, I think. Oh, I had that. Okay, we could place scripts like that. So when we are just using the script element like that, this is what happens with the page load. So the green bar being the rendering of the HTML and CSS, the blue being fetching the JavaScript from the server, and the red being executing the JavaScript, running the code. And this is what happens when you do that. And you see, that's why it's a good practice to place, if you're using the script tag, place it in the bottom of the page, because then all rendering has been done, more or less, before executing and loading and executing the script. You can change this behavior in modern browsers. You can add the async attribute, and adding async will make the script load asynchronously. So it will load in parallel with the rendering. So the browser will not stop the rendering for loading the script. However, when the script has loaded, the rendering will stop and the script will be immediately executed. Not that commonly used. It's kind of a special case. A more common use is the defer attribute. So you can place the script element in the head section of the page, and the script will load parallel to the page rendering. However, the execution of the script is deferred until the whole page has rendered the first time. Yeah.
Is everything that goes on with a page always single-threaded? There's never anything.
We will. You're jumping ahead, asking about single threading. I have a lecture on only that, because that is such an important concept. We don't need to worry about that right now. No, not everything is single-threaded per se. However, this is single-threaded. Well, in this case, it's not, obviously, because the network call is done in one thread and the rendering in another. But the rendering and the execution of JavaScript is always single-threaded, and that's why you cannot never overlap and have the rendering and the execution of a script at the same time. But we're skipping ahead. This works in most modern browsers, maybe not in Internet Explorer, but that is not a modern browser. Okay. Just a quick look at the folder structure. This is how the folders are structured in the assignments. source folder, a JS folder with the app.js, a CSS folder for the styles, and an index.html. Please feel free to change it. However, if you're using Webpack, like we do in the assignments and exercises, you need to change some things inside of the Webpack config. The Webpack config is pre-configured for this folder structure, and this folder structure is even given to you when you download or make a git subtree to receive a exercise. You will get this folder and those files pre-configured, even though it's more or less empty. Okay, still living in the notion that we are loading the script using the script tag in the way I showed, maybe at the bottom of the page to get maximum compatibility. There is a problem, and that is that everything in the browser is global. So when you write a JavaScript, it's executed in the same context as every other script on that page, and they are kind of executing together. If you do something like this, let temp equals 22, we create a function called myFunction, we increase the temperature by 12. Well, that was, yeah, I know why. If you look at that code, is there something wrong with that code? Something that I've forgotten, maybe? If you just look at the syntax.
Return maybe?
A return, yeah, it should probably return, but it will return undefined in this case. I forgot to instantiate that variable, right? Yeah, so I didn't write let increase temp by 12. I forgot. And that is valid JavaScript. What that does, that is a shorthand for saying make this variable global. So by forgetting to writing let or var or const before a variable name, it will be global. So if you were to do this, console log window.temp, this one, temp, it will say 22, because this file app.js is executed in the global scope. So when I just create a variable like that, that is the same thing as saying window.temp equals 22. And window is the global object in the browser. Every other script can call window and get the temp. So that is a super global variable. I'm not sure, but you've probably discussed global variables in other languages, and that global variables is kind of a bad thing. This is even worse because I only forgot. I didn't even mean to make this increase temp by global, but since I forgot to write let or var, it became global. So it stuck to the window object. If this is by design or actually a fault in the language, we could probably discuss, but this is one of the bad things with JavaScript, that everything sticks on the global object. And there is a saying that if you pollute the global object, Douglas Crockford eats a kitten. So please don't. We love our kittens. You should never place anything on the global object.
Hold up, what are you adding to when you do temp plus equal?
So that one.
Yeah, where should it still be 22?
It's not. It's fault. It should say 35. No, 34. Yeah. I'm not sure why I did that wrong, actually. Yeah, but that one is added. Yeah, so it should say 34 and 12. Never ever place anything on the global object. That is just bad practice. Because if you add a username to window and another application running at the same time on the page also needs a variable called username and adds it to the window object, then you share that username and you will get a lot of bugs. And it's just bad practice. But we shouldn't think about this too much, but know that this is happening. And this is actually fixed by using ECMAScript modules. Because if we are starting to using ECMAScript modules, window, one thing. First of all, if you try this in the browser, it will work. If you write use strict at the top, it will not work. So use strict will prohibit this behavior. That is one thing with use strict. Okay, so you always add use strict and you will not get into this bug at least. However, a better way nowadays is to use this called ECMAScript modules, ESM. All major browsers support it. I think we could have like they changed the UI, as I said, for Chrome. Can I use modules? Yeah. This one. So the support is pretty good. Edge, Firefox, Chrome, Safari, iOS Safari is supporting it. However, Samsung Internet is not. So that is probably if you have like a Samsung Galaxy, is it running that one Samsung Internet as default?
So,
Yeah, or are everybody kind of switching to Chrome anyways? I don't know.
I don't know.
Because that is kind of a problem. If Samsung Galaxy phones can't, or Samsung phones can't access your page if you're using modules, then you have a problem. But otherwise, the support is really, really great today for modules. It's a really, really simple trick to add ECMAScript modules to your page. You just add type module to the script element. Type module is not recognized by older browsers, and if they don't recognize the type of a script, they will not execute it. So older browsers will skip this line and will not load that script. But modern browsers will load it. Then we can do like this. Script, no module, source, JS, old.js. Actually, I would call it build instead of old. Okay, like that. So you can still add a script at the bottom of the page. You can write the attribute no module. Old browsers will ignore that one. And they will load the build.js file. So you can serve your page with one using ECMAScript modules in a modern way, and then you can have another version that works in older browsers. Oh, that must be hard to maintain. Well, not really, because as you see on the exercises and the examination assignment, we have Webpack, which is a build system that will look at app.js and follow all the dependencies to all modules and create something that works for older modules and call it build.js. So you will not need to think about that. But if you look at the exercises and go into the HTML, you will find this construction. You will find the type module in the head section, and you will find the no module at the bottom of the page. Okay, but we have no defer here, right? So shouldn't this like stop the execution of the page, the rendering? No, when you use type module, defer is standard. So you don't need to think about it. If you're using modules, this script will be deferred to the bottom of the page and executed after, or asynchronously loaded during the rendering and then executed when the rendering stops. So it's deferred automatically. That is wrong. Should say JS there. When you look in some examples, you will see the file extension MJS, Michael Jackson script. but it's called that, and I don't know why, but MJS probably stands for modules, moduled JavaScript. That file extension is often valid as well. You can use the file extension MJS for your modules if you like, and there is a big debate going on how to implement those ECMAScript modules into Node. And as of right now, the recommended way to do that is to call ECMAScript modules MJS files and old JavaScript modules JS files. But in the browser, there is no consensus yet. And I've chosen to stick with the JS file extension, and that is because standard JS will not recognize the MJS extension, hence it will not lint your code. So in this course I will stick to the JS extension, but you might see code that says MJS on some sites. Okay, so what does this, because this is a rare opportunity for the browser vendors to fix things that was faulty before, because the only browsers that are able to run those scripts are modern browsers, and modern browsers supporting ECMAScript 2015. And that is also a good way, because if the code is executed in a browser, you know that that browser is a compatible browser. Internet Explorer will never ever run this file because it will not be able to. So it fixes some things. First of all, you don't need to write useStrict. useStrict is enforced. It's there as a standard. So things that you could do wrong in old JavaScript, like forgetting to initiate a variable or instantiate a variable, declare a variable, sorry, with let, you cannot do that in modules. You will get an error when you're running the code. Top level variables are local to the module, and this is really important. In the old way of doing it, the window object was where all the variables got. So in this case, if I created let temp equals 22, it got stuck on the window object. It will not do that anymore. It's more like in Node that it's its own namespace. Each and every module is its own namespace. Nothing will leak if you are not explicitly telling it to leak. Modules loaded this way is only executed once. If you add the script element to app.js 10 times without no modules, the script will execute 10 times and load 10 times, probably cached, but anyways. In a module, it's only evaluated once. So if you get some kind of different modules depending on the same a common module, it will only have to be loaded once, because it will kind of do this dependency tree and see all dependencies and plot all dependencies. And it's executed asynchronously. So this, I haven't got, it was late last night. I think it works like this, that if you inside of a script, if you say that, oh, I want to load another module or import another module, instead of just synchronously wait, it will load the module and start executing that module. In this case, it will asynchronously load that module, release the thread, we will get back to this, and when it's loaded, it will continue the execution where it stopped. That is quite important when it comes to the browser, because it's single-threaded, but more about that later on. Just know that there are some benefits of using ECMAScript modules. Last week, I showed you how to require an module.exports code. So if you're in if you're writing a class, say a circle class, and you want other modules to use that class, you need to export it. And in node modules, or common JS modules as they are called, you do that by writing export module.exports and an object that will be exported from this module. And then on the other side, if you want to use the circle, you do a require circle. I showed that last week. That's how you do it in Node. And that's how we used to do it in the browser, but had Webpack just abstracting everything away from us, or just not compiling that into other code. But now when we can do this natively in the browser with ECMAScript modules, the syntax is kind of different. But I think you will manage. So if you look at this example, we can import from other modules using the import command. And inside of brackets, we could specifically tell what we want to import. It's a long time since I wrote Java, but I kind of think this kind of reminds of Java in some way. Don't you have like import and... But it doesn't work the same way, maybe. I don't remember. However, in this case, it says import A as B. So in foo.js, foo.js must have exported something called A. And we're telling, oh, in my context, in context of the page, let's call A B instead. So this says import A as B from foo.js. So then we could do B dot something, if it's an object, or if it's a number, we can just plot B. But A will not be present in this context. We can do an import A from foo.js. This is simpler. We're just saying, okay, import A. I want to use A. I want to use circle from foo.js. And then you can use circle. You can use the star as well. You can import star as nspace from foo. Then you will get an object called nspace, and everything exported in foo will be stuck to that object. So you can do like an nspace.a or an nspace.b or an nspace.c, whatever was exported from foo.js. And if we look in foo.js, we export by using the export command. So we have the import and we have the export. In this case, we export A as B. Those are not related. Because in this case, if we just look at the first line, it says that foo will export one thing, and that is A, but it will be called B. So from the outside, foo is exporting B. And we would have to do an import B from foo to get that exported object or whatever it is. You can, of course, just export A if we like and call it what it's called. And we could even export an expression like let's see. So in this case, it will export undefined. Or it will export C, but C is undefined in this case. However, how you will use it is probably like this, if you want to use the class syntax. And this is, I think this looks quite clear. Oh, I must forgot. Okay, might work. I'm actually this is like, I haven't used those for more than a couple of hours. So I'm pretty sure you need brackets surrounding my class. Must have forgotten that. I need to change it. But in foo.js, we export the class. There are so many errors in this one. Just a minute. I'll correct it. Where is that one then? Too many files. Hope it's her. Oh, it's not. Ah. First one. It should say that. No. Yeah, it should. Thank you. Any more things I've done wrong?
The name of the file, myclass.usa.
Yeah, that is also. I was tired yesterday. No, I think it's correct. Okay, like that. So in the app.js, we import my class from the file myclass.js. In certain environments, you can skip .js. However, not in the browser, not that I've managed anyway. So you need to specify the file. You need a // though, in the same way as with require, because that will indicate that this is not a built-in module, that this is a module that will be loaded from the file system. So // new class, just to initiate a new instance of that class. In the myclass.js, we export class myclass, and then we have the class. So it's quite a neat syntax. There's a lot of things that we can say about import and export, because it works in completely different way than require does. But I would actually recommend looking at this talk. I think it's a Chrome developer that talks about how this is done under the hood with the dependency trees and circular references and how that is handled. So if you want an in-depth look at this, look at that recording. The examinations and exercises are prepared in this way. So you are supposed to use this syntax in the exercises. However, if you like, you could use other syntaxes as well. Yeah, just a brief look at the developer tools in the browser. I've shown them already. You can do a lot of things with the tools. What you need to remember is that when you develop for the web, you develop in your IDE, but that the code is executed in the browser. You can set up the IDE or the development environment to debug even with a connection to the browser, but that is quite cumbersome. The easiest thing is to just debug in the browser itself. So if you, for instance, go into, I'll do it on this page. If you go into the console, you find all of those tabs in the top. Elements we've looked at before. This is just a representation of the HTML page. Remember though, this is not the code you have written. This is an interpretation of the code that you have written. So if you have written faulty code, faulty HTML code, this is the corrected version of your code. So if you're kind of looking at your HTML code on your development environment and it doesn't match when you're trying to apply JavaScript, a good practice is to also look here and see if something is changed, because that could actually happen. You have the console, and this is where you just could log things. You will get all error messages in the console. You might even get JS standard errors in the console, because Webpack will inject them as errors in the console. So a good thing is to have a look here if something is not working. In sources, you find all files in the project. In your case, let's see if we have. Okay, so in this case we're using a library called Reveal, and the revealed JavaScript file is here. You will find your files under source JavaScript and app.js, and you can look in the files, look at your code, and this code will be exactly what you've written. This is not interpreted. You can add debug or breakpoints just by clicking. Then you reload the page, and it will stop the execution at the breakpoint. And as you're used to in other languages, you have, now this is really crammed together because I want you to see it, but You have a watch down here. You can add your watch expressions. You can see the call stack. You have your normal controls to step into, step over. This is exactly like a normal debugger. A simple way of stopping the debugger as well, if you're writing in your, if I'm in Visual Studio Code and you want the debugger to stop on a certain row, you can always just write debugger. So if you write that statement somewhere in the code, the debugger will stop at that. That will inject a breakpoint at that line. And that is pretty neat, because then you, I mean, if you're sitting and coding in Visual Studio and you know that I want the breakpoint at this line, you just write debugger, go to the page, reload it, and the debugger will stop. You no need to find the file or things like that.
So does the entire browser just stop?
Yeah, the browser stops. It freezes. So the rendering stops at the, I mean, the thread is halted. So everything freezes. Even the cursor, if the cursor was in a down blink or an up blink, so to speak, it will stay in that position. On the network, you can find all network traffic. This is useful when we are starting to working with network traffic. Doing asynchronous communication with the server, using HTTP request objects, or working with WebSockets. And WebSockets will be used for the chat application, for instance, in the last assignment. Then you could go into the network and you can watch the network traffic and see what is actually going on. Pretty useful. And of course, all of those tabs has a lot of fine-tuning you can do, and filtering and recordings, and yeah, that's a lot. Performance, I will not go into this one, but you could, if you have performance issues with your script, your game, or whatever you're writing, you can start a recording and you can record what is happening, what is eating memory, what is using the CPU or the GPU or whatever. We will skip this totally in this course. The same with memory allocations. If you have a script that is running out of control and needing memory, you can examine that using the memory tab. What I would like to look into is the application tab, because this one we will use in the course. So under application, you can find detailed information about, for instance, the persistent layer in the browser, the data, what's it called? Storage, the storage in the browser. So I said we had something called web storage, that is local and session storage. So if you, for instance, are writing word processor or online code editor or something, so the user is writing code. You would hate it if the network connection is lost, the user reloads the browser, and all changes are gone. You need a way to store all changes as the user writes in the browser. You can do that using local storage. That is a persistent layer in the browser. It's capped. You cannot store 2 gigs in it. I think it's like 20 megabytes or something like that. But it's totally fine for smaller use. You have databases, an index database, IndexedDB. Though one of those, I don't remember which one, is deprecated and will not probably be used anymore. I think it's WebSQL. I'm not sure. I should remember this. You can look at the cookies that this page has set. In this case, you can look at the cache when we start working with the cache, and we can look at something called service workers. That is a really hot topic. We will look at that in the later parts of the course as well. But everything is, you can look at it here, you can clear the storage and work with the cache in this application tab. That is pretty much what I want to show right now. Good. Questions?
This local storage, how does that compare to cookies in terms of like tracking?
So local storage, how is that compared to cookies, for instance, for use for tracking? Local storage is just a storage area. It's a name value storage area. So you have a key value storage area. It's only available for the site that sets that, the domain that sets the storage. So you cannot really use it as, well, maybe you could if you're loading a remote script. We will get into that. Then CORS comes to play and all of that. So more on that on the security. Oh, it's the door. On the security lecture. But local storage, just look at this as a simple way of storing data in the browser. However, if we look into the more law or restricted by the law things, I mean, it's called a cookie law, that you are always supposed to tell the user that you're using cookies. In the law, it doesn't say cookies. It says if you're storing data on the user terminal, then you're supposed to inform. So the same thing actually complies to local storage. And actually, the cache is I think, an exception. But the laws are really not up to date with the technology in this case. And we will see that service workers, for instance, that's a really tricky business, because service workers are actually JavaScript code running in the background in your browser without you visiting the page. So for that is how, for instance, if you are surfing the web, you can get a Facebook notification even though you are not on Facebook. And that is because Facebook has a service worker in the background waiting for notifications. And when a notification shows up, it uses the notification API to show that notification for the user. That is built into Android in a much neater way. So it will be native notifications in Android from the browser. But we will talk about that as well in the later parts of the course. Service workers are this really, really interesting topic, and it's will change how web applications are designed, more or less, if all browsers implement them. Safari has been like, ooh, but I think it's a green light from Apple as well right now. It will actually, service workers will kind of change the whole App Store thing as well, because we will be able to create more or less native applications using the web APIs, which is interesting. But more on that on a later note. Okay, so we need a break. We need a kind of an hour and 8 minutes break for lunch. Then we will start looking at the concept of DOM, the document object model, which is a really important part when it comes to writing JavaScript web applications. Okay, thank you.